Picture this. You wake up tomorrow morning, but something is terribly wrong. The bed beneath you has vanished. Your clothes are gone. You're lying naked on cold, hard ground. Around you, millions of others are experiencing the same terrifying realization. The buildings, the roads, the cars, everything humanity has built over thousands of years has disappeared. You've been transported back to 8000 BCE, the Stone Age. But there's a twist. You still have all your memories, all your knowledge from the 21st century locked inside your mind. And then, echoing in your head, comes a message in your native language. Build a computer with a graphical user interface, and you'll all return to 2018. This is the ultimate test of human civilization. Can we rebuild from absolute zero? How long would it take to go from naked and afraid to creating a functioning computer? The answer might surprise you or terrify you. Let's start with the immediate crisis. Within seconds of arriving in 8000 BCE, millions are already dead. Anyone who was in an airplane? Gone. Those on upper floors of buildings? They fall into their deaths. People who were swimming in deep water drowned instantly. Ships at sea? Everyone aboard has plummeted to the ocean floor, which is now dry land since sea levels were different 10,000 years ago. But the real killer hasn't even started yet. It's December in the Northern Hemisphere. Billions of people who were indoors with heating are now exposed to winter conditions with no shelter, no clothes, no fire. In places like Canada, Scandinavia, and Russia, the temperature could be negative 20 degrees Fahrenheit or colder. A naked human in those conditions? Dead within hours, maybe minutes. We've just lost another billion people, a minimum. The survivors face an immediate challenge that modern humans are desperately unprepared for. How do you make fire without matches? How do you find food when you don't know which plants are edible? How do you get clean water? Most of us can't answer these questions. We're specialized. A software engineer might know how to code a GUI, but can they knap flint into a cutting tool? Can a surgeon perform surgery without instruments? Can a farmer grow crops without seeds? Here's where human nature becomes our biggest enemy. When resources are scarce and death is imminent, cooperation breaks down. The cities become killing fields. 7 billion people fighting over the few edible plants and small animals in the immediate area. Within days, every rabbit, every bird, every edible root from miles around populated areas is gone. Starvation sets in quickly. The social order collapses completely. It's not about building computers anymore. It's about surviving the next hour. But let's be optimistic. Let's say pockets of humanity manage to organize. University towns might have the best shot. You've got agricultural experts, engineers, metallurgists, computer scientists, all in one place. They band together, share knowledge, work toward the common goal. But even then, the challenge is staggering. To build a computer, even a simple one, you need electricity. To generate electricity, you need copper wire and magnets. To make copper wire, you need to mine copper ore, build a furnace hot enough to smelt it and draw it into wire. But wait, to build that furnace, you need bricks. To make bricks, you need clay and a kiln. To build a kiln, you need tools. To make tools, you need to mine iron ore. To mine anything effectively, you need pickaxes, which means more metalworking. See the problem? Every technology depends on 10 other technologies. It's like trying to build the top floor of a skyscraper when the bottom 99 floors don't exist yet. And we haven't even talked about food production. The carrying capacity of Earth for hunter-gatherers is about 10 million people. We have 7 billion. Even if 90% die in the first week, which is optimistic, we still have 700 million mouths to feed with Stone Age technology. The math doesn't work. We need an agriculture immediately, but we don't have domesticated plants or animals. Modern wheat doesn't exist, cows don't exist, chickens don't exist. We'd have to start the entire agricultural revolution from scratch, a process that originally took thousands of years. Let's say, miraculously, a group survives the first year. They figured out basic tools, shelter, and food production. They've started writing down crucial knowledge before the people who possess it die. They begin the long journey toward the computer. First, they need to reinvent written language and create an education system to pass knowledge to the next generation. Then mining and metallurgy. Then precision tool making. Then chemistry to create insulators and other materials. Then the printing press to spread information. Then industrial machinery. Then electronics. Each step takes years, maybe decades. The computer itself is the easy part, relatively speaking. The prompt doesn't require a modern computer, just something with a basic GUI. With 1940s technology, you could build something that technically qualifies. Vacuum tubes for logic gates, a simple cathode ray tube for display, mechanical switches for input. It would be the size of a room and have less processing power than a calculator, but it would meet the requirements. But here's the cruel irony. The knowledge exists in people's heads right now. We know how to build computers. The problem isn't the knowing, it's the doing. It's the 10,000 prerequisite technologies. It's the infrastructure. It's keeping people alive long enough to build that infrastructure. Realistically, if humanity is incredibly lucky, if the right people survive in the right places, if cooperation triumphs over competition, if knowledge is preserved and passed down effectively, we might see a working computer in 50 years. That's assuming everything goes right. More likely, it takes centuries. The first generation spends their entire lives just trying to survive and establish basic agriculture. The second generation begins mining and metallurgy. The third starts building complex tools. By the time someone builds that computer, the original transported humans are long dead. Their great-great-grandchildren flip the switch that brings everyone back to 2018. But here's the darkest possibility. What if we never make it? What if the knowledge dies with the first generation? What if humanity splinters into warring tribes, forgetting the mission entirely? Earth could be littered with the ruins of our attempted recovery. Half-built furnaces, abandoned mines, crude attempts at electronics, while our descendants live as hunter-gatherers, telling myths about the before times when humans flew through the sky and spoke across vast distances. The computer challenge isn't really about building a computer. It's about everything that makes a computer possible. It's about civilization itself, cooperation, specialization, accumulated knowledge, infrastructure. Take those away, and even with all our modern knowledge, we're just naked apes trying not to die. So next time you flip open your laptop or pull out your smartphone, take a moment to appreciate it. That device represents not just advanced technology, but 10,000 years of human progress, millions of innovations building on each other, billions of people working together across generations. It's civilization in your pocket. And if we lost it all tomorrow, getting it back would be humanity's greatest challenge, and possibly our final failure. Think about the specialized knowledge that would be lost immediately. How many people actually know how to make glass from sand? How many understand the chemical process for creating rubber? Who remembers the exact mixture for concrete? These aren't things we Google in the Stone Age. The experts who know these processes by heart are probably less than 1% of the population, and they're just as likely to die in the initial chaos as anyone else. Even if the right experts survive, there's another problem. Modern knowledge is built on abstractions. A programmer knows that clicking a mouse sends an electrical signal that the computer interprets as coordinates on a screen. But how many programmers know how to make a mouse from scratch? How to mine and refine the plastics? How to create the optical sensor? How to manufacture the tiny ball bearings or laser components? Each person knows their narrow slice, but almost nobody knows the whole chain. Consider something as simple as making paper to write down what we know. You need wood pulp, which means cutting down trees. But with what? Stone axes would take forever, so you need metal axes, which means smelting, which means building furnaces that can reach 2,000 degrees Fahrenheit. Just to make paper, just to preserve knowledge, every simple thing becomes a monumental project. The psychological toll would be devastating too. Imagine knowing that somewhere in your mind is the knowledge to build smartphones and satellites, but you're spending your days digging roots with a stick and hoping you don't die of dysentery. The frustration would be unbearable. Many would simply give up on the computer goal entirely, focusing instead on making their primitive life as comfortable as possible. There's also the question of whether building the computer is even the right goal. If a group manages to create a sustainable agriculture and basic technology, why risk it all trying to jump to electronics? They've already solved the survival problem. Their children are fed. They have shelter. Is it worth gambling that stability on a moonshot attempt to build a computer that might not even work? And remember, the message says everyone returns to 2018 when the computer is built. But after 50 years or a century, how many people would want to return? The original transported generation would be dead. Their descendants would have known only this primitive world, Would they even believe the stories about the future past? Or would the whole thing become mythology, a creation story about the ancestors who came from the land of machines? The truth is, this scenario reveals how fragile our technological civilization really is. We like to think human knowledge and progress are permanent, that we've solved the basic problems of survival. But take away the infrastructure, scatter the specialists, remove the supply chains, and we're back to square one. 10,000 years of progress gone in an instant. Perhaps the real lesson isn't about building computers at all. It's about recognizing that every piece of technology we use, every convenience we take for granted, exists only because of an unbroken chain of development stretching back to the first human who figured out how to control fire. Break one link in that chain and everything that comes after disappears. So could humanity build a computer from scratch after being sent back to the Stone Age? Yes, eventually. But the cost would be measured in generations of struggle, billions of deaths, and the very real possibility that we might fail entirely. The computer on your desk isn't just a machine, it's the culmination of all human achievement. And starting over, that's not just a technical challenge. It's asking whether humanity itself could survive its own reset.